Hey everyone, welcome to the Speedrun Web3 Hackathon, where we're going to build some Web3 dApps in our spare time. It's actually a perpetual hackathon, so you can just work on it anytime. But here we are on the ICP page, and this is what we're going to be working on. So let's go here and see what kind of apps can be built on internet computer. Well, here is one. This is Office X. It is essentially a crypto version of Microsoft Office. And if we go to it, you can see it has, this is actually just a new account altogether. And it just works out of the box. There's no sign up. There's no email. Instead, it uses cryptographic identities. So like you could give this, for example, to an AI agent and they could be part of your company. And you wouldn't even be able to take the login away from them because they have cryptographic guarantees. So all sorts of new organizations can be formed internet native like this. So here we have are in the hackathon, and we're just going to quickly go over the timeline. Whoops, my bad, I went back. We're just going to quickly go over the timeline, and then we're going to run an ICP HTTP canister locally using TypeScript. Right, so let's begin. The hackathon, you can imagine that if you're watching this video right now, the hackathon has indeed started. And don't worry about your app, your dApp, decentralized app, not winning. That is not the point of the hackathon. The point of the hackathon is to speed run you through Web3 and so that you can enter this blue ocean of apps that are available to be monetized. Right? Like all these developers are all competing in the Web2 space, and there's copies of copies, and it's very saturated. But there is so much opportunity in Web3, and it is a gold rush for developers. It's an absolute blue ocean. There's only 30,000 developers worldwide building on Web3, and there's literally hundreds of billions, almost trillions of capital. If you look at like volume of like money being spent and traded around, it's in the trillions, relying on 30,000 developers. So yeah, like it doesn't matter if your dApp doesn't win because you've speed run Web3. The criteria for evaluating projects is there's like multiple streams. Some are based on like the technical difficulty, some are just like real world impact, and then some are just like, does this have potential to like create an ecosystem out of it, right? But again, don't worry really about like winning the hackathon as much as speed running and getting like a working app out. Are there guidelines or formats we should follow when submitting our project? So yes, there is. You do need to include the hackathon.md file in your GitHub repo, and you need to submit your GitHub repo. You do not need a demo video, but you should have a demo video filmed. I mean, like how many times have we all like done a project and coded all this stuff, and in the end we didn't even like film like a tutorial video, right? So like make sure you do that. It'll help your repo live on and be evergreen and let people continue to use it. So yeah, that's it. And we are indeed building an MVP right now. You don't need to have all the features. And yeah, it is self-paced. So yeah, if you do get a dApp through the finish line, you feel like it has potential, like we will actually help you with the marketing, and like free of charge. And yeah, like but if you're not like committing to it, we probably won't. But yeah, you don't need to have like all the answers. You don't need to have like a clear decision on how you're even going to implement Web3. You could just have a minimum implementation, and then the important thing is that you really understand and have the aha moments of what the big deal is with Web3, and then you can always like add more Web3 features later. So I hope that answers some of the basic questions about the hackathon. Definitely, like if you have more, just type them out. We'll try to answer it. But now we can move on to the technical portion of the hackathon, which is like the getting started with TypeScript, and HTTP canisters. Before we jump into that, let me actually explain what makes Internet Computer so special that you can't find on other blockchains like Ethereum and Solana. Blockchains are isolated environments that don't have access to the rest of the internet because the rest of the internet cannot be trusted. It's not a shared state. Like if you think about the internet and Web 2, it is essentially like a bunch of companies have their own databases and they control it, and like they could change the database values at any time. There is no shared global state. There's no shared source of truth. You have to trust a centralized entity or like a few entities to tell you what the truth is. The blockchain is a global shared hard drive, global shared state, and you don't need to trust anyone because the whole world looks at the same blockchain, and we use cryptography to ensure that everything is like legitimate. So when you spend money, right, it's you spending the money. You chose to. You weren't forced to. Someone didn't fabricate your transaction. And it's because in order for you to spend your money on the blockchain, you need to have the private key, the password. Right? And the public key, of course, is your wallet address. And like in aggregate, all these stories is why together being on the blockchain is why they say blockchain is technology for canon. What is canon? Canon is the human story that gets written down, right? And so like all these things happened in the world over history, and the transactions show that like this person paid this for coffee, or like this person like escaped this country with this and paid this like border guard or whatever, right? Of course, it's all obfuscated, right? Like you can spin up unlimited wallets. So anyways, it's a deep topic, but what makes Internet Computer special is that it is the only blockchain that can actually connect to the rest of the Web 2 internet. And specifically, it allows you to build HTTP REST servers. No other blockchain can do that. And that's why the most opportunities for Web3 apps is actually on Internet Computer. And it just so happens that it's a very like maturing technology. It's been worked on for 8 years. I think it's been dismissed too early by a lot of like the Web3 community and developers. So there's actually not many developers building on Internet Computer, and yet there is the most opportunities. So that's Internet Computer, and why it's so important is that it's the only one that can run HTTP smart contracts. So let's just dive into it. JavaScript is the English of coding. So in order to make this available to the most developers, we're going to actually do this all in TypeScript. Now, if you want, you can also do it in Rust and like Python and all these other languages as well, but we're going to use TypeScript. So let's actually go to the boilerplate. Let me pull it up right now. Give me a second. All right, great. So what I have here is a GitHub boilerplate repo, quick start ICP TS TypeScript. So what we're going to do is we're going to git clone this. So let's just do that here. All right, and if you'll bear with me. All right, great. So here we are inside the code. And let's just take a look at the README. All right, recommend to use Node 22. Okay, let's see my Node version. Okay, cool. Well, I guess we don't have Node installed on this computer. Okay, cool. We'll install Node there. Okay, great. So now we're going to install something called dFX, which is the command line terminal for Internet Computer. So we can install it here. Yeah, you can just use the default installation. Okay. Now let's just check it that it's working properly. Okay, fantastic. So we're good there. Great. So now let's create a simple sample application called Hello World. Right. So this is going to install something called Azle. Azle is the framework for writing Internet Computer canisters, aka smart contracts, using JavaScript or TypeScript. So we'll just install that. Okay, we'll just install. Okay, it's installed, and now let's go inside the program. Oh, actually, you know what? Sorry. The quick start is actually the Azle program. So we can actually go inside our quick start. Like, it's actually the same. It's slightly different in that, like, there was a few things that were in the boilerplate is like confusing, or like something in the documentation that was slightly off. So use the boilerplate just like because it also solves some of those issues. But also the important thing is you have this Hackathon MD file. You don't have to use the boilerplate, but you do need to include this Hackathon MD file in order to qualify for the hackathon. So yeah, now let's continue on. npm install. And while that installs, let's actually just take a look at like the submission details. So there's the hackathon name. This would be speedrun web 3. I think summer season. Now this is based on your project. Like, you know, you might have a consumer app, or you might be like, I don't know, like trading or whatever. So you can put anything you want here, really. Then your project name, just a quick short description. Now mainnet canister ID. So this is important when you deploy your app to the mainnet, to the blockchain. You will get a canister ID that references your blockchain app. So this needs to be submitted. And again, doesn't need to be like a full-on backend, right? Just some minimum functionality is fine. And then a link to your demo, if possible, your contributors, the date, location, this one's optional, and your email and Twitter handle or other social media, also optional. Yeah, and then the I agree consent. So yeah, that's the hackathon.md file, very important to include. All right, great. So now we've installed npm. Let's actually deploy dFX, right? So, or start the dFX. So what does this do? What does it mean to start dFX? This means that we are going to have a local instance of the internet computer blockchain running locally on our computer. And now when we develop, we can point to it and do all sorts of stuff. And this is really important because transactions on any blockchain cost gas, cost money. So if we were to develop and just use mainnet as our test environment, well, that would be very expensive. You'd be paying gas for everything. And this could easily be hundreds of dollars. If you do it on testnet, much cheaper, but you're still going to have to find like gas tokens, which you can get for free, but you're still going to have to go find them somewhere. So that's why local is best, because you can just print yourself more tokens. Okay, cool. So now you can see that DFX is running locally on our computer at port 4943. Okay, so now in a separate terminal, we are going to deploy. So we go into here. I'm going to use the VS Code terminal, and I'm just going to DFX deploy. And oh shoot, it says DFX not found. Hold up, we just installed DFX. Okay, DFX deploy. There we go. All right, so now it's deploying. You can see it's creating a canister, creating a wallet on the local network. The wallet is different from the canister. The wallet is where it holds your crypto, and you are able to pay for gas and stuff. Because remember, crypto, or like Web3, is when you use the world's computer, not the world computer, the world's, because anyone can join the network and volunteer their computer. So it's the world's computer, but it all has the same shared state. But in order to do that, those computers cost electricity, bandwidth to keep the lights on, and that's what when you pay gas, that's what you're paying for, is that network of trustless computers. Cool. So now it is running, and right. So we have here the canister that was deployed. So now it is on our local computer's blockchain, and you can see here at the end this and ID equals BKZK. This is the canister ID. So like when you deploy it to mainnet, like it would be like, you would replace it here. Cool. So we can actually like open this link and see what it looks like. Like there will be like a interface where we can actually like interact with it, right? Now, this means nothing. Like you would have to send raw HTTP requests over here, and you would have to like convert it to like bytecode or something. I forget what it is, but you do have like maybe base64. I don't know. But anyways, it is running. View your web front end on a web browser here, right? So actually, if we go here, and then we get the ID, which is this BKZ. We can see here the app, right? And it says database timestamp, right? This is the current time. If I post, we're going to update the time. You can see the timestamp has now changed, right? So this is just a database value in your canister. So let's actually look at the code and see how it works. Yeah, you can also just like use raw HTTP just like this. But anyways, let's see how it works. So if we go into here, go into the back end, there's a single TypeScript file, and you can see it's literally just using an Express endpoint, and you just classic REST API. Right? Any TypeScript web developer, when they see this, you know exactly what's going on, and you can just bring your own like framework if you want, like whatever you use. I'm not sure like what the full range of compatibility of frameworks is, but definitely Express.js works. And like really big applause to the team at Demergent Labs for making this Azul library super important to the ecosystem. And then if we look at the front end, it's just a simple HTML file where It's just doing a fetch request, HTTP GET to your backend. So you can also bring your own backend, right? And that's the beauty of like developing apps on internet computers, that they're just like Web 2 apps. Now you do get into more nuance as you dive in to try to build complex apps. Like for example, like database, right? When you use a database, most of the time, smart contract developers actually choose not to use a pre-built database, and instead they just use hash tables. Like for example, like this is literally what it looks like, right? And you would directly manipulate these values. You would directly manipulate these values. And like, yeah, a lot of like smart contracts are actually that. So if you're used to like the luxuries of like SQL databases and like all these libraries and packages, well, unfortunately, you probably won't have access to most of those. But it's okay, because if you're not afraid to go slightly low level and use these data structures and algorithms directly, you'll be completely fine. Actually, you'll find it very refreshing because it minimizes your dependencies. And it doesn't limit what amazing complex apps you can make. So yeah, like as a web developer, this boilerplate should be very like directly simple, and you know how to get things going. If you want to deep dive into kind of like the framework, you can like read the Azul book here. Azul is like how you get TypeScript into ICP. And I think like databases, I would be interested in databases. Oh, look at this, cool, we can use SQLite. Incredible. Okay, cool, so you can have a SQL database. Sorry, the reason why I don't really know this is because I actually just write it in Rust directly. So yeah, I mean, I am a TypeScript guy, but like I really like using like the Rust environment for smart contracts. But yeah, like the TypeScript is also really good and very developer friendly. So yeah, that is the hackathon, the first episode of the webinar. If you have any questions, just like drop in the chat, and hopefully we'll get on a group call even and answer some of your questions live. Thanks everyone. Have a ton of fun on the hackathon.